Hi Year 11s, this next video is on the derivative function. So differentiation is the algebraic process used to find the gradient function of a given function. So the word derivative can actually be known as the rate of change. It can also be known as the gradient. So if you're finding the derivative of a function at a certain point, you're actually finding the gradient at that point. Now, in your booklets, from booklet 1, there is a page of information on rates of change. So what I would like you to do now is pause this video if you are watching online, go and read that page of the booklet because it will just give you some background information on the next thing I will talk about and then restart the video again. So pause the video now and go and read that. Alright, hopefully you did what I asked and pause the video. As it was said in that rates of change information, you can have an average rate of change, instantaneous rate of change. Now, some things that link to that is when we look at these two things, a secant and tangent. So a secant is a line that intersects 2 points on the curve. That's the green line. You see it intersects the curve at 2 different points. So we use this to find the average rate of change. So we find the gradient of that line. And a tangent to a curve at a specific point is a line that touches the curve at that point. So that's that pink line there. You see it's against the curve and it just actually intersects with the curve once. And that will help us find the instantaneous rate of change. Now with a tangent line, you can also have it at a certain point. If you carry the tangent line on, it might intersect the curve at another point. That is fine. Because we're looking at a tangent, we're just looking at that point, that pink dot there, the one that we've said, this is the point I want to look at on this curve. So we only concentrate on the specific point that we've been given. Okay, so derivative notation. So there's more than likely 3 different ways you'll see derivatives. So if we have the function f of x, the derivative of that is f dash x. Now be really careful here. A lot of people get confused with this and the inverse. So the inverse is the -1 of x. A derivative is a dash. So please be aware that they are different. They're not the same thing. And just look at what the question's asking you. If you've been given a function that's y equals, you can write y dash. Or sometimes you will see dy over dx. So this basically means the change in y over the change in x, or the change in y with respect to the change in x. Now, we're going to look at some rules for derivatives. So we've got a few here to start with. So we have the power rule. If f of x equals x to the power of n, then the derivative equals n times by x to the power of n minus 1. The constant rule, so if the function is just a constant, so a random number, then the derivative of that is 0. The constant multiple rule, so if we have a constant multiplied by a function, like 3x squared, 3 will be the constant, x squared is the function, then the derivative of that is the constant multiplied by the derivative. And the sum difference rule, if you have a function where you have something with x in plus or minus something else with x in, then you just do the derivative of each one separately. We're going to do a few examples now that integrate all these different rules so you can see how they work. Now, example 1, find the derivative of each of these functions. So the first one, we have x to the power of 11. So to find the derivative of this, it's that first rule, it's the power rule. So the rule is if we have something to the power of n, then the derivative is n multiplied by the function and minus 1 from the power. So our derivative of x to the power of 11 will be, we'll write f dash x equals, so the 11 comes down the front, x stays the same, and then we minus 1 from the power. So 11 minus 1 is 10. The next one, y equals 1 over x to the power of 4. Now we don't like fractions with derivatives, so what we want to do first is rewrite this without a fraction. Now we just do our derivative as we would do normally. So dy over dx, I'm going to use that notation, equals, the -4 comes down the front, and then we minus 1 from the power, -5. So this is where some people make silly mistakes in an exam. Under the pressure, they'll do -4 plus minus 1 is -3, not -5. So just be aware of that one. And then you can rewrite this if you would like with positive indices. C, the main part of C is you have to recognise that the square root of x is the same as x to the power of a half. When you're doing derivatives with square roots, you always want to change it to the power of a half. And then the derivative's the same. So y dash, bring the half down the front, x, and then a half minus 1 will be negative a half. All right, let's start bringing some other things into our equations. So we've got the function of 3 over x to the power of 12. So we've got over x to the power of 12. Remember, we don't like the fractions, so we are going to rewrite this first. 3x to the power of a negative 12. The same thing, but now it just looks a bit nicer. And here we have the constant multiple rule because we have a value that 3, a constant, multiplied by the function. So when we do the derivative of this, to start with, that 3 stays there, and we're going to multiply that by the derivative of x negative 12. So we bring the negative 12 down. We have our x, and we minus 1 from the power, that would be negative 13. And then we just simplify. So 3 times negative 12 will be negative 36, x to the power of negative 13. And then if you want to write that with a positive power, you can put the x to the power of negative 13 onto the denominator, and it will become x to the power of 13. We've got y equals 5 plus 3x squared. So now we've got a plus in the middle. Now remember, if we have something plus something else, then we just do each bit separately. So for this one, y dash, now derivative of 5. So this is the constant rule. So if you've got just a number, the derivative of that is 0. The plus or minus stays the same. Now we've got the derivative of 3x squared. So the 3 stays the same, and times by, we bring the 2 down, have the x, and minus 1 from the power. And then we'll just simplify. So the 0 plus will disappear. We're going to have 3 times 2, which is 6, and x to the power of 1 is just x. F, we will look at different ways of doing this, but for now, if it looks simple like that, honestly, the easiest way is to expand the brackets first. So we'd have t squared minus 2t plus t minus 2. So t squared minus t minus 2. All right, and then from here, we just do the derivative. So now you see how our value here, our variable here is an s, which means we need to do s dash for our derivative. Now, derivative of t squared, 2 comes down the front. T will stay the same, minus 1 from the power, which will just give us 2t to the power of 1. Now minus t. So we've got to think of this as like a minus 1t. The power of t on its own is just 1. So when we do the derivative of a variable with a power of 1, that's going to end up being, when we minus 1 from the power, it's going to be to the power of 0. So it ends up just being whatever the number is in front of the variable. So that would just be minus 1. And minus 2 is a constant, and remember, a derivative of a constant goes to 0. So our final answer will be 2t minus 1. And remember, with your notation here, if you wanted to, you could have also written it as ds over dt. Either of those is fine. All right, g. So we've got f of x equals 2x to the power of 4 minus 3x cubed plus 1 all over x squared, and x cannot equal 0. And obviously x can't equal 0 because we can't divide by 0. Easiest way I find to do this is just put each thing separately over x squared. So I have 2x to the power of 4 over x squared minus 3x cubed over x squared plus 1 over x squared. And then we can simplify things. So this first one will become x to the power of 4 divided by x to the power of 2 gives us x squared. 3x cubed divided by x squared will give us 3x. And 1 over x squared will give us x to the power of minus 2. And then because they are all adding and subtracting, we just do each one separately. So f dash x will equal the 2 stays, times by, bring the 2 down, x minus 1 from the power, 3x. Remember, if we have a single x, we just drop the x, so we'll end up with minus 3. And then we're going to bring here the minus 2 down and minus 1 from the power, so it would be minus 2x minus 3. And then simplify, so 2 times 2 is 4x minus 3 minus 2 to the power of x negative 3, so we can write that with a positive indice if we wish. They're not very strict on the IB with positive indices with this. If you left it as the power of negative 3, you'd still be marked correct. And the last one, we have y equals 3 times the 5th root of x plus 8. So we're going to rewrite this so it looks like something we can work with. So we've still got 3 now. Remember, little 5 root x is the same as x to the power of a 5th plus 8. Okay, now we can do the derivative. So we're going to be 3 times, bring the power down the front, so the 5th x, 1/5 minus 1 will give us negative 4/5, and then plus 8, derivative of, remember, a constant just becomes nothing, so we don't need to write anything. Then we can simplify this, so we'll have 3 on 5, x to the power of negative 4/5. And if you want to write that with a positive indice, you can do so. It'll be 3 on 5, x to the power of 4/5. Alright, that is it for this video. What you can do now is, from booklet 1, you can do pages 4 to 8, which is lots of different questions with using all these different rules. And if you have any questions, please just send me an email and I will get back to you when I can.